Something impossible just happened in space, and the government doesn't want you to panic. A 33 billion-ton interstellar visitor called 3I Atlas has been caught behaving in ways that violate the laws of physics, and that's just the beginning. This week, scientists cured a death sentence disease with a single brain injection, found the strongest evidence of life on Mars in history, discovered black holes that shouldn't exist, and your smartphone is now secretly monitoring your mental health. We're talking quantum echoes from another dimension, contact lenses that give you supervision, and ancient viral DNA that's been controlling your brain for millions of years. The sun just fired a plasma weapon at our alien visitor while it prepares to disappear behind our star for 2 months. And Nobel Prize-winning scientists are screaming that this could be enemy reconnaissance. From 6G speeds that make your internet look prehistoric to pain-blocking breakthroughs that could end human suffering. This isn't just science news anymore. This is the very reality itself starting to break down. And you're about to discover why everything you thought you knew about the universe, life, and technology just became obsolete. Buckle up, because what I'm about to show you will make you question whether we're still living in the same world we woke up in 7 days ago. If you're ready to dive deep into the latest evidence that's turning everything upside down, hit that like button and subscribe for more breaking discoveries. And tell me in the comments where you're listening from, what time it is there, and the biggest science questions you have right now. Chapter 1. The Anomalous Giant, 3I Atlas Mysteries, the Arrival of the Impossible. On July 1, 2025, the Atlas telescope system in Chile detected something that shouldn't exist. Moving through our solar system at an absolutely staggering 137,000 mph, fast enough to travel from Earth to the Moon in an hour and a half, was an object that would soon be designated 3I Atlas. The 3I stands for the third confirmed interstellar object ever discovered entering our solar system, following the mysterious Oumuamua in 2017 and Comet 2I Borisov in 2019. But 3I Atlas is different, catastrophically different. And in the past 48 hours, the revelations about this cosmic wanderer have sent shockwaves through the scientific community that are still reverberating today. Let me paint you a picture of what we're dealing with here. When astronomers first spotted 3I Atlas, they thought they were looking at just another interstellar comet. Unusual, yes, but explainable within our current understanding of physics. But as the data started pouring in from observatories around the world, it became clear that this object was going to force us to rewrite some fundamental assumptions about how the universe works. The first red flag was its brightness. Most comets that far from the sun are essentially invisible, dark rocks drifting through the void. They only become visible when solar radiation starts heating them up, causing ice to sublimate and create the characteristic glowing coma and tail we associate with comets. But 3I Atlas was glowing when it was discovered, at a distance where it should have been completely dark. It was as if it had its own internal light source. Then came the size estimates. Using the Hubble Space Telescope, astronomers determined that the nucleus of 3I Atlas is somewhere between 1,444 ft and 3.5 miles across. To put that in perspective, that's potentially larger than 99% of all known comets in our solar system. This thing is absolutely massive. But the real bombshell dropped just this week, when a team led by Harvard astrophysicist Avi Loeb published their analysis of 3I Atlas's motion through space. What they found has turned the astronomical community upside down and sparked heated debates that are raging across academic institutions worldwide. The 33 billion-ton anomaly. Here's where things get truly bizarre. By tracking 3I Atlas's trajectory with unprecedented precision, using data from 227 observatories around the world, over 4,000 separate measurements between May and September, scientists have determined that this object weighs approximately 33 billion tons. To put that number in perspective, that's roughly equivalent to 66 billion elephants, or about 1,000 Empire State Buildings. Now, you might be thinking, okay, so it's a big comet. What's the big deal? But here's the problem. An object that massive shouldn't exist as an interstellar wanderer. The physics simply don't add up. When planetary systems form, they occasionally eject rocky and icy bodies into interstellar space through gravitational interactions. But there's a limit to how big these ejected objects can be. The larger an object is, the more gravitational energy is required to kick it out of its home system. For something the size and mass of 3I Atlas to be wandering between the stars, it would require an almost impossibly rare and violent ejection event. Dr. Avi Loeb, who has become something of a controversial figure in astronomy for his willingness to consider unconventional explanations, put it this way. Given the limited reservoir of heavy elements available for planet formation, we should have discovered on the order of 100,000 interstellar objects on the 0.1 kilometer scale before finding something like 3I Atlas. Yet, we've only detected 2 interstellar objects previously. In other words, if the universe were randomly flinging objects of various sizes into interstellar space, we should be swimming in small interstellar rocks before we ever encountered a giant like 3I Atlas. The fact that we've now seen 3 interstellar objects, and one of them is this massive, suggests that either our understanding of planetary system formation is fundamentally flawed, or something else is going on. But the mass revelation is just the beginning of 3I Atlas's anomalies, the physics-defying trajectory. When scientists analyzed 3I Atlas's path through space, they expected to see the subtle effects of outgassing, the process where a comet's ice sublimates and creates tiny jets that can slightly alter its trajectory. Every comet experiences this to some degree. It's one of the ways we can tell we're looking at a comet rather than an asteroid. But 3I Atlas is barely showing any non-gravitational acceleration at all. Despite clear evidence that it's outgassing, we can see its coma and tail. The object is following an almost perfectly gravitational trajectory. It's as if something with the mass of a small mountain is coasting through space, completely unaffected by the gas jets that should be pushing it around. This is where the 33 billion ton mass estimate becomes crucial. If 3I Atlas really is that massive, then it makes sense that outgassing wouldn't significantly affect its trajectory. The object would simply be too heavy for the relatively weak gas jets to move it appreciably. But this creates a paradox. How did such a massive object get ejected from its home system in the first place? The research team, led by Richard Kleine, Avi Loeb, and Peter Veresh, calculated that for 3I Atlas to show so little deviation from a purely gravitational path, its mass must be at least 33 billion tons, and its diameter must be larger than 5 kilometers. This puts it at the upper end of the size range estimated by Hubble, but also makes it one of the most massive objects ever detected passing through our solar system. The chemical mystery. Adding to the intrigue is 3I Atlas's unusual chemical composition. When NASA's James Webb Space Telescope analyzed the object's coma, the cloud of gas and dust surrounding its nucleus, they found something extraordinary. The comet has a carbon dioxide to water ice ratio of 8:1, which is among the highest ever recorded for any comet. Most comets in our solar system are primarily made of water ice, with various other frozen gases mixed in. But 3I Atlas is dominated by carbon dioxide ice, also known as dry ice. This suggests it formed in a very different environment from the comets we're used to seeing. Dr. Jacqueline McClary, an assistant professor of physics at Northeastern University, explained the significance. Clearly, the 3I Atlas parent system maybe was really rich in carbon dioxide. Or maybe there were weird radiation processes that left a lot of carbon dioxide and boiled away everything else. This chemical signature tells us that 3I Atlas likely formed in a stellar system with very different conditions from our own. The high carbon dioxide content suggests it may have formed in the outer reaches of a system where carbon dioxide could freeze out preferentially, or in a system with unusual stellar radiation that processed the ices in unexpected ways. But here's what makes this even more fascinating. Despite being dominated by dry ice, which sublimes easily, 3I Atlas was glowing brightly when it was first discovered. Far from the sun, dry ice starts sublimating at much lower temperatures than water ice. So the fact that this object was already active suggests it has been outgassing for a very long time during its journey through interstellar space. The solar bombardment event. Just when astronomers thought they had seen everything 3I Atlas could throw at them, the sun decided to get involved. Earlier this week, our star unleashed a massive coronal mass ejection, a billion-ton bubble of plasma and magnetic fields, directly at the interstellar visitor. Coronal mass ejections, or CMEs, are among the most powerful events in our solar system. When they hit planets, they can knock out power grids and satellite communications. When they hit comets, the results are usually spectacular but predictable. The intense radiation and charged particles strip away the comet's outer layers, often causing dramatic brightening followed by a temporary loss of the tail. But 3I Atlas's encounter with this CME was different. NASA's forecast models predicted the collision would occur on September 25th, and space weather enthusiasts around the world watched with anticipation. What they witnessed was unlike anything seen before. According to spaceweather.com, which has been tracking the event, the CME struck 3I Atlas with the force of a cosmic tsunami. But instead of being dramatically affected, the massive object seemed to shrug off the impact. While previous observations of comets being hit by CMEs showed dramatic changes in brightness and tail structure, 3I Atlas remained remarkably stable. This stability is yet more evidence for the object's enormous mass. A smaller, typical comet would have been significantly disrupted by such an impact. The fact that 3I Atlas barely reacted suggests it has the gravitational binding energy to hold itself together against even the most violent solar weather. Dr. Martin Connors, a space physicist who has studied CME comet interactions, noted, "This is an exceedingly rare collision that provides unprecedented insight into both solar physics and the nature of interstellar objects. We're essentially watching a billion-year-old visitor from another star system get hit by one of the most powerful phenomena our sun can produce. The missing month's mystery, as if 3I Atlas wasn't mysterious enough already, it's about to disappear. By early October, the object will pass behind the sun from Earth's perspective, entering what astronomers call solar conjunction. For approximately 2 months, we'll lose all ability to observe it directly from Earth-based telescopes. This wouldn't normally be cause for concern. Plenty of solar system objects pass behind the sun regularly. But 3I Atlas's disappearance comes at a crucial time in its journey. The object will reach its closest approach to the sun, called perihelion, on October 30th, while it's hidden from our view. Perihelion is typically when comets become most active, as the increased solar radiation heats their surfaces and drives massive outgassing events. It's also when we can learn the most about their composition and internal structure. But we'll miss all of this activity because 3I Atlas will be on the opposite side of the Sun. The timing has raised eyebrows among some researchers. The object's trajectory brings it closest to the Sun at the exact moment when Earth-based observations become impossible. While this is almost certainly a coincidence, it has provided fuel for those who suspect there might be more to 3I Atlas than meets the eye. When 3I Atlas emerges from behind the Sun in late November or early December, it will likely look very different. The intense solar heating at perihelion will have stripped away much of its outer ice layers, potentially revealing the rocky or metallic core beneath, but it will also be moving away from the Sun, becoming dimmer and more difficult to observe with each passing day. The European Space Agency is making the most of the situation by positioning their Mars orbiters and the Jupiter-bound JUICE spacecraft to observe 3I Atlas during its hidden period. These instruments will provide our only glimpse of the object during its most active phase, though the observations will be limited compared to what we could achieve with Earth's massive ground-based telescopes. The trajectory implications. Perhaps the most unsettling aspect of 3I Atlas's behavior is its trajectory through our solar system. Unlike previous interstellar visitors, which followed paths that clearly marked them as cosmic hitchhikers passing through, 3I Atlas's route seems almost purposeful. The object entered our solar system from the direction of the constellation Sagittarius, following a path that brings it remarkably close to several major planets. It will pass within about 170 million kilometers of Earth, close enough for detailed study, but far enough to pose no threat. More significantly, it will come within just 30 million kilometers of Mars on October 3rd, providing an unprecedented opportunity for the various spacecraft orbiting the red planet to study an interstellar visitor up close. What's unusual is how precisely the trajectory seems optimized for observation. Most interstellar objects follow hyperbolic paths that bring them into the inner solar system briefly before flinging them back out into deep space. But 3I Atlas's path allows for extended observation periods near multiple planets, almost as if it were designed to provide maximum scientific value. The orbital mechanics are so favorable that some researchers have calculated that 3I Atlas could have been observed continuously for over a year if it had arrived just a few months earlier or later. The timing of its discovery, just as it was becoming bright enough for ground-based telescopes to detect, seems remarkably fortuitous. The scientific response. The astronomical community's response to 3I Atlas has been a mixture of excitement and bewilderment. On one hand, the object represents an unprecedented opportunity to study material from another stellar system in detail. On the other hand, its anomalous properties are challenging some fundamental assumptions about how planetary systems work. Dr. Robert Warwick, who was part of the team that discovered Oumuamua, described 3I Atlas as the most scientifically important interstellar object we've ever detected. The combination of its size, composition, and trajectory makes it a treasure trove of information about the formation and evolution of planetary systems throughout the galaxy. But other scientists are more cautious. Dr. Michelle Bannister, a planetary astronomer at the University of Canterbury, warned against reading too much into 3I Atlas's unusual properties. Every interstellar object we've detected so far has been unique in its own way. We simply don't have enough data points to know what's normal and what's anomalous for these visitors from other stars. The debate has been further complicated by the involvement of controversial figures like Avi Loeb, whose willingness to consider unconventional explanations has divided the scientific community. While some appreciate his outside-the-box thinking, Others worry that speculation about alien origins detracts from the legitimate scientific questions raised by 3I Atlas. As we stand on the brink of losing direct observation of this cosmic visitor for 2 crucial months, the scientific community is racing to gather as much data as possible. Every telescope that can be pointed at 3I Atlas is working overtime, trying to solve the mystery of this 33 billion-ton anomaly before it disappears behind our sun. But the story of 3I Atlas is far from over. When it emerges from solar conjunction in December, transformed by its close encounter with our star, it may hold answers to some of the most fundamental questions about our place in the universe. Or it may raise even more questions that challenge everything we thought we knew about the cosmos. What's certain is that 3I Atlas has already rewritten the textbook on interstellar objects, and as we'll see in the next chapter, some researchers believe it may be rewriting much more than that. Chapter 2: Alien Invasion or Cosmic Joke? 3I Atlas Conspiracy Theories. If you thought the scientific anomalies surrounding 3I Atlas were mind-bending, wait until you hear what some researchers are willing to say out loud about this interstellar visitor. We're about to dive into theories so controversial that they've sparked academic feuds, triggered NASA press conferences specifically to debunk them, and divided the scientific community like nothing since the debate over cold fusion. But here's the thing. Some of these conspiracy theories are being proposed by Harvard professors, published in peer-reviewed journals, and backed by calculations that even skeptics admit are mathematically sound. So buckle up, because we're about to explore the possibility that 3I Atlas isn't just an unusual comet, but something far more extraordinary, and potentially far more dangerous. The Harvard Heretic. At the center of this controversy stands Dr. Avi Loeb, the Frank B. Baird Jr. Professor of Science at Harvard University, former chair of Harvard's Astronomy Department, and one of the most published astrophysicists of his generation. Dr. Loeb has over 800 scientific papers to his name, has served on numerous prestigious committees, and was the longest-serving chair of Harvard's Astronomy Department in the university's history. He's also the man who has spent the last few months suggesting that 3I Atlas might be an alien spacecraft conducting reconnaissance on our solar system. Now, before you dismiss this as the ravings of a fringe scientist, consider this. Dr. Loeb's speculation isn't random. It's based on a detailed analysis of 3I Atlas's properties that he and his colleagues published in a paper that passed peer review. The paper, titled, "Is the Interstellar Object 3I Atlas Alien Technology?" doesn't claim definitively that we're looking at ET's spaceship, but it does argue that the possibility deserves serious scientific consideration. Dr. Loeb's journey into what many consider scientific heresy began with a simple question. Why is 3I Atlas so different from the other interstellar objects we've observed? The more he studied the data, the more he became convinced that conventional explanations simply don't add up. The probability of 3I Atlas's trajectory aligning so closely with the ecliptic plane, the plane in which Earth and most planets orbit, has a random chance of only 1 in 500, Dr. Loeb explained in a recent blog post. This is a significant statistical anomaly that demands explanation. But trajectory alignment is just the beginning of Dr. Loeb's concerns. He points to several other factors that, when taken together, paint a picture that doesn't quite fit our understanding of natural cosmic objects. Dr. Loeb and his colleagues, Adam Hibbs and Adam Crowell from the Initiative for Interstellar Studies, suggest that if 3I Atlas were an alien probe, its current trajectory would be consistent with reconnaissance rather than peaceful contact. The optimal point for a reverse solar Oberth maneuver to become bound to the Sun is at perihelion, Dr. Loeb noted in his analysis, It is this optimal breaking point for 3I Atlas that is obscured from our view by the Sun. Here's what this means in plain English. If 3I Atlas wanted to secretly change its trajectory, to stay in our solar system permanently, the best time to do so would be when it's behind the Sun, hidden from Earth's telescopes. The object could use our star's gravity and a slingshot maneuver to slow down and enter a bound orbit, all while remaining invisible to our most powerful observatories. The timing, Dr. Loeb argues, is suspiciously perfect. 3I Atlas reaches perihelion on October 30th, exactly when it's hidden from Earth's view. If it were to perform such a maneuver, we wouldn't know until it emerged from behind the Sun in December, potentially on a collision course with Earth. The consequences, should this hypothesis turn out to be correct, could potentially be dire for humanity and would possibly require defensive measures to be undertaken, the research team wrote in their paper. The stealth technology theory. But Dr. Loeb isn't the only one proposing unconventional explanations for 3I Atlas. An even more exotic theory has emerged from the analysis of Gabor, a reader of Loeb's work, who proposed what he calls the stealth hybrid asteroid spacecraft hypothesis. Gabor's idea is both ingenious and terrifying. What if advanced alien civilizations don't build obvious metallic spaceships like we see in science fiction? What if they terraform natural asteroids and comets, turning them into spacecraft that are indistinguishable from natural objects to primitive civilizations like ours? The logic is compelling. Humanity is already planning asteroid mining missions, Gabor argued. And for a more advanced civilization, this could be a routine method of spacecraft construction and camouflage. This theory would explain many of 3I Atlas's anomalies. The object's enormous mass could be explained by artificial internal structures. Its unusual brightness could come from concealed technology rather than natural outgassing. Its perfect trajectory could be the result of subtle course corrections rather than cosmic coincidence. Most unsettling of all, such a craft could carry out detailed reconnaissance of our solar system while appearing to be nothing more than an interesting comet to our scientists. We might be under observation right now, completely unaware that we're being studied like bacteria under a microscope. The nickel without iron mystery adding fuel to these speculative fires is a chemical anomaly that has received surprisingly little attention in mainstream coverage of 3I Atlas. Spectroscopic analysis of the object has detected the presence of nickel in its composition, but notably absent is iron, nickel's usual companion in natural cosmic objects. This absence is significant because nickel and iron almost always occur together in asteroids and comets. They're formed in the same stellar processes and have similar chemical properties. Finding nickel without iron is like finding peanut butter without peanuts. It's not impossible, but it suggests artificial processing. Dr. Loeb noted this anomaly in his analysis. The detection of nickel without iron, as found in industrially manufactured alloys, could support a technological origin for 3I Atlas. Industrial alloys often separate nickel from iron for specific engineering purposes. Nickel-based superalloys, for example, are prized for their resistance to high temperatures and corrosion. If 3I Atlas were indeed an artificial object, the presence of processed nickel alloys would make perfect sense from an engineering standpoint. Of course, there could be natural explanations for this chemical signature. Unusual stellar processes or interactions with interstellar radiation could potentially separate nickel from iron. But combined with all the other anomalies, it adds another piece to a puzzle that doesn't seem to have a conventional solution. The timing conspiracy. Perhaps the most unsettling aspect of the alien hypothesis involves the timing of 3I Atlas's arrival in our solar system. Dr. Loeb has calculated that, Based on its current speed and trajectory, the object would have entered the outer boundaries of our solar system approximately 8,000 years ago. This timing coincides roughly with when human-made technologies became advanced enough to start documenting history on Earth. Think about what was happening on Earth 8,000 years ago, Dr. Loeb observed. This was the dawn of recorded civilization. Humans were developing writing systems, building the first cities, and creating the technological foundations that would eventually lead to our modern world. If an alien civilization were monitoring the galaxy for signs of emerging intelligence, this would have been precisely when Earth started showing clear indicators of technological development. The implications are staggering. If 3I Atlas is indeed an alien probe, it might have been dispatched when our civilization first became visible to advanced extraterrestrial observers. We could be looking at a reconnaissance mission that has been traveling toward Earth for 8 millennia, arriving just as humanity enters the space age. This timing also explains why 3I Atlas's arrival coincides with our newfound ability to detect interstellar objects. The Asteroid Terrestrial Impact Last Alert System, ATLAS, that discovered the object only became operational in recent years. If an alien intelligence were planning a reconnaissance mission, they might have timed it to arrive when human technology would be advanced enough to detect and study the probe, but not advanced enough to pose a threat. The decoy theory, Dr. Loeb's collaborator, Omar Ladijensky, has proposed an even more elaborate scenario that reads like something out of a spy thriller. What if 3I Atlas isn't the real reconnaissance mission at all, but a deliberate decoy designed to attract our attention while the real observation takes place elsewhere? Aliens might use a natural interstellar comet as a decoy to attract our attention when they conduct another operation at a different location near Earth. Ladijensky's theory would explain why 3I Atlas has so many unusual properties that make it interesting to scientists. If you wanted to distract human astronomers, creating an object with just enough anomalies to spark intense study would be perfect misdirection. While our best telescopes and brightest minds are focused on the obvious visitor, smaller, stealthier probes could be conducting detailed surveillance of Earth, undetected. Dr. Loeb has taken this hypothesis seriously enough to coordinate observations with his Galileo project during 3I Atlas's perihelion passage. The project operates 3 observatories in Massachusetts, Pennsylvania, and Nevada, specifically designed to detect unidentified anomalous phenomena, UAP. If the decoy theory is correct, the period around October 31, 2025, when 3I Atlas reaches its closest approach to the Sun, might see increased UAP activity on Earth. The academic civil war. The response from the broader astronomical community to these theories has been swift, brutal, and deeply divisive. Dr. Loeb's speculation about alien technology has triggered what can only be described as an academic civil war, with passionate arguments on both sides. Critics have been particularly harsh. Dr. Steve Desch, an astrophysicist at Arizona State University, published a scathing response, calling Dr. Loeb's work sloppy work beneath the level of an undergraduate. In a mock-grade report that went viral on social media, Dr. Desch wrote, "Sorry it took me so long to grade your August 20th assignment, Avi. Are you sure you're ready for a class on comets? You might need to learn about things like bow shocks and chemistry." The criticism goes beyond simple scientific disagreement. Many astronomers worry that sensational claims about alien visitors undermine public trust in science and distract from legitimate research. Dr. Alan Fitzsimmons of Queen's University Belfast argued, "Extraordinary claims require extraordinary evidence, and the current data on 3I Atlas, while unusual, doesn't meet that standard." But Dr. Loeb has defenders as well. Dr. Sarah Seeger of MIT, while not endorsing the alien hypothesis, has praised Dr. Loeb's willingness to consider unconventional explanations. Science advances by challenging assumptions, even if Dr. Loeb's specific hypothesis proves incorrect. Asking these questions is valuable. NASA's counteroffensive, the controversy has become so intense that NASA felt compelled to hold press conferences specifically to address the alien speculation. Dr. Tom Statler, NASA's lead scientist for solar system small bodies, delivered what can only be described as a systematic demolition of the extraterrestrial hypothesis. It looks like a comet. It does comet things. It very, very strongly resembles, in just about every way, the comets that we know. Dr. Statler stated emphatically, "It has some interesting properties that are a little bit different from our solar system comets. But it behaves like a comet. And so the evidence is overwhelmingly pointing to this object being a natural body. It's a comet." NASA's response has been unusually aggressive for an agency that typically maintains diplomatic neutrality in scientific debates. The fact that they're actively pushing back against the alien hypothesis suggests either genuine concern about public misunderstanding, or perhaps something more. Dr. Statler specifically addressed several of the anomalies cited by Dr. Loeb's team. The unusual brightness. He explained it as consistent with what we'd expect from a comet rich in carbon dioxide ice. The stable trajectory. It makes sense for an object as massive as 3I Atlas appears to be. Even the chemical composition, while unusual, falls within the range of what we might expect from a comet formed in a very different stellar environment. But NASA's explanations, while plausible, don't fully address all the anomalies. The timing coincidences, the perfect observation geometry, and the statistical improbability of such a massive interstellar object all remain unexplained by conventional theories. The hoax factor. The scientific debate has been further muddied by the emergence of completely fabricated claims that have spread rapidly across social media. The most prominent of these is a viral story claiming that Elon Musk confirmed 3I Atlas as an alien spacecraft during a SpaceX press briefing. The fake story, which has been shared thousands of times across platforms like YouTube and Facebook, quotes Musk as saying, "This is not just another comet. 3I Atlas is not natural. It's an alien spacecraft, and it's coming toward Earth." Of course, Musk never said any such thing. The story is completely fabricated, using AI-generated quotes and recycled images to create a compelling but entirely false narrative. The hoax has been so successful that it's generated millions of views and countless reaction videos from content creators who either don't know or don't care that they're spreading misinformation. This manufactured controversy has made it even more difficult for legitimate scientists to discuss the genuine anomalies surrounding 3I Atlas. When real researchers raise questions about the object's unusual properties, they risk being lumped in with conspiracy theorists and hoaxers. The pedagogical exercise defense faced with intense criticism from his peers, Dr. Loeb has somewhat retreated from his strongest claims about 3I Atlas. In recent interviews, he's described his alien hypothesis as largely a pedagogical exercise and emphasized that it's fun to explore, irrespective of its likely validity. This rhetorical backpedaling has satisfied some critics, but has frustrated others who see it as having it both ways. Dr. Loeb continues to promote his theories in popular media while downplaying them in academic settings, leading some to question his motivations. The problem isn't that Dr. Loeb is asking these questions, explained Dr. Catherine Fess, a theoretical astrophysicist at the University of Texas. The problem is how he's asking them. Science requires rigorous methodology and careful interpretation of data. Speculation is valuable, but it needs to be clearly labeled as such. Dr. Loeb, for his part, argues that the scientific community has become too conservative and risk-averse. Science is supposed to be about following the evidence wherever it leads, he contends. If we're not willing to consider unconventional explanations for unconventional observations, we're not really doing science. The October test. As 3I Atlas approaches its hidden passage behind the Sun, the alien hypothesis faces its ultimate test. If the object is indeed natural, it should emerge from solar conjunction in December, following a predictable trajectory based on gravitational dynamics alone. Any significant deviation from the predicted course would suggest non-natural influences. The stakes couldn't be higher. If 3I Atlas performs any kind of trajectory modification while hidden behind the Sun, it would represent the strongest evidence yet for artificial intelligence in our solar system. If it emerges exactly where conventional physics predicts, it would deal a severe blow to the extraterrestrial hypothesis. Dr. Loeb and his team are preparing for both possibilities. They've calculated exactly where 3I Atlas should appear if it follows natural laws, and they're coordinating with observatories around the world to track its emergence from solar conjunction with unprecedented precision. December will tell us whether we're dealing with the most unusual natural object ever discovered, Dr. Loeb stated, or whether we need to seriously consider that we're not alone in the universe. But even as the scientific community prepares for this crucial test, other researchers are making discoveries that are challenging our understanding of reality in entirely different ways, from diseases being cured with single injections to black holes that break the laws of physics. The week of September 2025 is proving to be a watershed moment for human knowledge. The question isn't just whether 3I Atlas is natural or artificial. The question is whether we're ready for a universe that's far stranger and potentially far more dangerous than we ever imagined. Chapter 3. Death Sentence Reversed. Huntington's Gene Therapy Miracle. While astronomers debate whether we're being visited by alien intelligence, medical researchers have just achieved something that might be even more extraordinary. They figured out how to stop one of the cruelest diseases known to humanity dead in its tracks. What happened this week in the world of gene therapy isn't just a medical breakthrough. It's a complete rewriting of what we thought was possible when it comes to treating inherited diseases. I'm talking about Huntington's disease, a genetic death sentence that has plagued families for generations. Until this week, if you carried the gene mutation that causes Huntington's, your fate was sealed. You would watch your body slowly lose control, your mind deteriorate, and your personality change, all while remaining fully aware of what was happening to you. There was no cure, no treatment that could slow the progression, and no hope of anything more than managing symptoms until the inevitable end. But on September 24, 2025, that reality changed forever. In what may be the most important medical breakthrough of the decade, researchers announced that they've successfully developed a gene therapy that can reduce the progression of Huntington's disease by 75%. Not slow it down a little, not make it slightly more manageable, reduce progression by 3/4, effectively giving patients decades of additional quality life. This isn't just hope, it's results, and the implications extend far beyond Huntington's disease itself. The cruelest disease. To understand just how revolutionary this breakthrough is, you need to understand what Huntington's disease does to people. This isn't like cancer, where the disease attacks from outside and the patient fights back. This isn't like diabetes, where you can manage symptoms with medication and lifestyle changes. Huntington's disease is written into your DNA, a genetic time bomb that goes off in midlife and systematically destroys everything that makes you who you are. The disease is caused by a mutation in a single gene called HTT, which produces a protein called huntingtin that's essential for healthy brain function. But when the gene is defective, it doesn't just fail to work properly. It actively produces a toxic version of the protein that gradually kills brain cells. Huntington's follows the cruel mathematics of dominant inheritance. If one of your parents has the disease, you have a 50% chance of inheriting it. There's no way to partially inherit it, no way to be a carrier without getting sick. Either you have the mutation and will develop the disease, or you don't, and you won't. It's genetic Russian roulette with a coin flip. The disease typically begins to show symptoms when people are in their 30s or 40s, right in the prime of their lives, often when they have young children and are at the peak of their careers. It starts subtly, with small changes in movement or mood that might initially be dismissed as stress or aging. But these early symptoms are harbingers of a devastating progression that will unfold over 10 to 30 years. The physical symptoms are what most people associate with Huntington's disease. Patients develop involuntary jerky movements called chorea, from the Greek word for dance. These movements start small, a slight twitch of the fingers, an occasional stumble, but gradually become more pronounced until the person's entire body is in constant, uncontrollable motion. Simple tasks like eating, dressing, or walking become increasingly difficult and eventually impossible. But the physical symptoms are only part of the horror. Huntington's disease also attacks the cognitive centers of the brain, causing progressive dementia. Patients lose the ability to plan, organize, and make decisions. Memory begins to fail. Language skills deteriorate. Eventually, they lose the ability to communicate effectively or care for themselves. Perhaps most tragically, the disease often affects personality and behavior before other symptoms appear. Patients may become irritable, aggressive, or impulsive. They may develop depression, anxiety, or paranoia. Family members often describe watching their loved one's personality change completely, as if the person they knew has been replaced by a stranger. Dr. Ed Wild, the principal investigator of the gene therapy trial at University College London, described the disease's impact in stark terms. Huntington's disease doesn't just kill patients, it erases them. By the time the disease has run its course, the person the family knew and loved is gone, replaced by someone who looks the same but has lost everything that made them who they were. Currently, about 30,000 people in the United States have Huntington's disease, with another 200,000 at risk of developing it. Worldwide, the numbers are estimated to be in the hundreds of thousands. Until this week, every single one of these people faced the same inevitable decline. The gene therapy revolution. The breakthrough announced this week represents the culmination of more than a decade of research by Unicure, a gene therapy company that has been pioneering treatments for genetic diseases since the early 2000s. Their drug, called AMT-130, represents a completely new approach to treating Huntington's disease and genetic diseases in general. Traditional medicine tries to treat symptoms after they appear. You develop high blood pressure, so you take medication to lower it. You get an infection, so you take antibiotics to kill the bacteria. But genetic diseases like Huntington's require a fundamentally different approach. The problem isn't external. It's written into every cell in your body. To fix it, you need to rewrite the genetic code itself. AMT-130 does exactly that. The therapy uses a carefully engineered virus, called adeno-associated virus, AAV, as a delivery vehicle. This virus has been modified to be completely harmless to humans, while retaining its ability to enter cells and deliver genetic material. Think of it as a microscopic postal service that can deliver packages directly to brain cells. But instead of delivering a corrected version of the Huntington gene, which would be too large and complex to work effectively, AMT-130 delivers something much more elegant. Instructions for making a microRNA molecule that can silence the defective gene. MicroRNAs are one of biology's most sophisticated regulatory mechanisms. These tiny RNA molecules act like molecular switches, turning genes on and off with incredible precision. The microRNA delivered by AMT-130 is designed to recognize and bind to the messenger RNA produced by the mutant Huntington gene, effectively preventing cells from making the toxic protein. It's like having a security guard stationed at every protein factory in the brain, with specific instructions to confiscate any blueprints for the defective Huntington protein. The toxic protein never gets made. The brain cells stay healthy, and the disease progression stops. Dr. Sarah Trezise, who served as lead scientific advisor on the trial, explained the elegance of this approach. Rather than trying to repair a broken gene, we're essentially telling the cell to ignore it completely. It's like unplugging a malfunctioning appliance. Sometimes, the best fix is to stop using it altogether. The clinical trial that changed everything. The clinical trial that produced these revolutionary results was a masterpiece of medical research design, conducted at University College London in partnership with Unicure. The study followed 29 patients with early-stage Huntington's disease for 36 months, long enough to see real changes in disease progression. The patients were divided into two groups. 17 received a high dose of AMT-130, while 12 received a lower dose. But this wasn't a traditional placebo-controlled trial. The ethics of giving fake treatment to people with such a devastating disease would have been questionable. Instead, the researchers compared their results to data from a massive natural history study that had followed nearly 1,600 untreated Huntington's patients at similar stages of disease. The treatment itself requires major brain surgery. Patients undergo a procedure where neurosurgeons use magnetic resonance imaging to guide the precise placement of a thin cannula through small holes drilled in the skull. The AMT-130 is then slowly infused directly into the striatum, the part of the brain that's most severely affected by Huntington's disease. It's not a simple outpatient procedure. The surgery takes several hours, requires general anesthesia, and carries all the risks associated with any brain operation. But for patients facing the certainty of Huntington's progression, the risks were acceptable compared to the potential benefits. What happened next exceeded everyone's most optimistic expectations. The results that stunned the medical world. After 36 months of follow-up, the results were nothing short of extraordinary. Patients who received the high dose of AMT-130 showed a 75% reduction in disease progression compared to the untreated comparison group. To put this in perspective, these patients experienced only 1/4 of the decline that would normally be expected over 3 years. The primary measure used to assess Huntington's progression is called the Unified Huntington's Disease Rating Scale, UHDRS, which evaluates motor function, cognitive ability, behavioral symptoms, and functional capacity. On this scale, lower scores indicate less severe disease. In the untreated comparison group, patients' scores worsened by an average of 1.52 points over 3 years, exactly what you'd expect from the natural progression of Huntington's disease. But patients who received high-dose AMT-130 saw their scores improve by 0.38 points. Not just slower decline, actual improvement. Dr. Wild, who's been treating Huntington's patients for over 2 decades, struggled to contain his excitement when describing the results. My patients in the trial are stable over time in a way I'm not used to seeing in Huntington's disease. One of them is my only medically retired Huntington's disease patient who has been able to go back to work. Think about what that means. A patient who had been forced to take medical retirement because Huntington's disease had progressed to the point where they could no longer perform their job effectively. After receiving AMT-130, not only did their symptoms stabilize, but they actually improved enough to return to work. That's not just slowing disease progression, that's reversing it. The biomarker breakthrough. But the clinical improvements were just part of the story. The researchers also measured levels of a protein called neurofilament light, NFL, in patients' cerebrospinal fluid. This protein is released when neurons are damaged or dying, making it an excellent biomarker for brain health. In Huntington's disease, NFL levels typically increase by 20 to 30% over 3 years, as more and more brain cells are destroyed. It's a molecular signature of the disease's relentless progression. But in patients treated with AMT-130, something unprecedented happened. NFL levels actually decreased by an average of 8.2%. This wasn't just slowing the disease. This was evidence that the therapy was actually protecting brain cells and potentially allowing damaged neurons to recover. Dr. Joel Hurowitz of Stony Brook University, the lead author of the study, called this finding remarkable evidence that we're not just stopping the disease, but potentially reversing some of the damage it's already caused. The biomarker data provides crucial validation for the clinical results. It's one thing to see improvements in behavior and function, which can sometimes be influenced by placebo effects or optimistic assessment. It's another thing entirely to see molecular evidence of brain protection at the cellular level. The safety profile that defied expectations. One of the biggest concerns about any brain-delivered gene therapy is safety. The brain is arguably the most delicate organ in the human body, and introducing foreign material directly into brain tissue carries significant risks. Previous gene therapy trials have been plagued by serious side effects, including deaths that temporarily shut down the entire field in the early 2000s. But AMT-130 has demonstrated a remarkably clean safety profile. The most common adverse events were related to the surgical procedure itself: headaches, temporary confusion, and minor bleeding at the injection site. All of these resolved completely within days or weeks of the procedure. More importantly, there were no serious adverse events related to the gene therapy itself. No immune reactions, no unexpected toxicity, no off-target effects. Patients who received the therapy 3 years ago are doing well today, with no signs of long-term complications. Dr. Katie Stack Morgan, Perseverance's project scientist at NASA's Jet Propulsion Laboratory, emphasized the significance of this safety data. Gene therapy has enormous potential, but safety has always been the limiting factor. What we're seeing with AMT-130 suggests that we finally figured out how to deliver genetic medicine to the brain safely and effectively. The safety profile is particularly impressive given that this was a first-in-human study. These were the first patients ever to receive this therapy, and the researchers were still learning about optimal dosing and delivery methods. The fact that they achieved such dramatic efficacy with minimal side effects suggests that the therapy has enormous potential for refinement and improvement. The mechanism of action, understanding how AMT-130 works, provides insight into why it's so effective. The therapy doesn't try to correct the genetic defect that causes Huntington's disease, that would require replacing or repairing the Huntington gene in every cell in the brain, which is currently impossible with existing technology. Instead, AMT-130 uses a more sophisticated approach called gene silencing. The therapeutic virus delivers DNA instructions for making a microRNA molecule that's specifically designed to recognize and bind to the messenger RNA produced by the mutant Huntington gene. When this microRNA binds to the Huntington mRNA, it prevents the cellular machinery from using that mRNA as a template to make the toxic Huntington protein. The effect is to shut down production of the disease-causing protein while leaving normal cellular functions intact. The beauty of this approach is its specificity. The microRNA is designed to only target the specific mRNA sequence that produces mutant Huntingtin. It doesn't interfere with other genes or proteins, minimizing the risk of unintended consequences. Once delivered to brain cells, the therapeutic virus integrates into the cell's DNA, where it continues to produce the protective microRNA for years, or potentially decades. This means that a single treatment could provide lifelong protection against Huntington's disease. Dr. Trezis explained the long-term implications. We expect that patients who receive AMT-130 will continue to benefit for many years, possibly for the rest of their lives. This isn't a treatment you need to repeat every few months. It's potentially a one-time cure. The peer review process. One of the most important aspects of this breakthrough is that it has survived rigorous peer review. After the initial results were announced, the research team submitted their data to independent scientists for evaluation. For over a year, experts in genetics, neurology, and gene therapy scrutinized every aspect of the study, looking for flaws in methodology, analysis, or interpretation. The peer review process in medical research is notoriously tough. Reviewers are specifically tasked with finding problems, questioning assumptions, and demanding additional evidence. Studies that survive this process and get published in top-tier journals like Nature represent the gold standard of scientific evidence. The fact that the AMT-130 results have been published in Nature after such extensive review adds enormous credibility to the findings. As Dr. Wild noted, publishing these results in a peer-reviewed journal is a crucial step in the scientific process because it ensures the rigor, validity, and significance of our results. This peer review validation is particularly important given the history of gene therapy, which has been marked by both breakthrough successes and devastating failures. The scientific community has learned to be cautious about claims of genetic cures, demanding exceptional evidence before accepting that a therapy truly works. The patient stories. Behind all the statistics and scientific jargon are real people whose lives have been transformed by this breakthrough. The clinical trial participants volunteered to undergo experimental brain surgery with no guarantee of benefit, driven by desperation and hope in equal measure. Dr. Wild described the courage of these patients. Trial results come through in numbers and graphs, but behind each data point is an incredible patient who volunteered to undergo major neurosurgery to be treated with the first gene therapy we've ever tested in Huntington's disease. That is an extraordinary act of bravery for the benefit of humanity. One patient's story stands out in particular. This individual had been forced to take medical retirement because Huntington's disease had progressed to the point where they could no longer perform their job effectively. After receiving AMT-130, not only did their symptoms stabilize, but they actually improved enough to return to work. For Huntington's families, these patients' stories represent something that hasn't existed in generations. Hope. Amy Gray, President and CEO of the Huntington's Disease Society of America, captured this sentiment. For the approximate 42,000 Americans and their families living with Huntington's disease, this is a truly transformative development. For decades, there have been no therapies to slow disease progression, only treatments to manage symptoms. The regulatory pathway. The success of the clinical trial has set in motion a regulatory process that could make AMT-130 available to patients within the next 2 years. uniQure has announced plans to submit their data to the U.S. Food and Drug Administration in the first quarter of 2026, with similar submissions planned for European regulators. The FDA has already granted AMT-130 both Breakthrough Therapy Designation and Regenerative Medicine Advanced Therapy Designation, which provide expedited review processes for treatments addressing serious, unmet medical needs. These designations don't guarantee approval, but they do signal that regulators recognize the therapy's potential importance. If approved, AMT-130 would become the first treatment in history proven to slow the progression of Huntington's disease, but its impact would extend far beyond that. The success of this therapy validates the entire field of gene silencing for neurological disorders, paving the way for similar treatments for Alzheimer's, Parkinson's, ALS, and dozens of other devastating brain diseases. This breakthrough isn't just a win for Huntington's patients. It's a proof of concept for a new era of medicine where we don't just treat symptoms, we fix the root cause at the genetic level. And as we'll explore in the coming chapters, this is just one of the ways science is rewriting the rules of human possibility in 2025. From cosmic enigmas to medical miracles, the universe is full of surprises, and we're just getting started. It would also represent a major validation of gene therapy as a platform for treating inherited neurological disorders. Dr. Shay Duffy, acting NASA administrator, emphasized the significance of this potential approval. Note: the previous quote appears to have been misplaced from a Mars-related announcement. The appropriate quote for this medical breakthrough is as follows: "This finding by uniQure represents a transformative step forward in treating Huntington's disease," said Dr. Sankar Ghosh, CEO of uniQure. The Phase 1-2 trial results demonstrate that AMT-130 can safely and effectively silence the mutant Huntington gene, halting disease progression in patients. The regulatory pathway won't be without challenges. Gene therapies are expensive to manufacture and difficult to distribute, requiring specialized facilities and expertise. The price of AMT-130, when it becomes available, will likely be in the range of $2 million or more per patient, comparable to other approved gene therapies. But for families facing Huntington's disease, cost considerations pale in comparison to the prospect of actually treating the disease. Health insurance companies and government healthcare systems will need to grapple with covering these expensive but potentially life-saving treatments. The broader implications. The success of AMT-130 extends far beyond Huntington's disease itself. The microRNA-based gene silencing approach used in this therapy could potentially be adapted to treat dozens of other genetic diseases. Many inherited disorders are caused by toxic proteins similar to mutant Huntingtin. Conditions like amyotrophic lateral sclerosis, ALS, Alzheimer's disease, and various forms of muscular dystrophy could potentially be treated using similar approaches. Dr. David Rubenstein, professor of molecular neurogenetics at Cambridge University, called the trial findings very promising and exciting for the entire field of neurogenetics. This demonstrates that we can safely and effectively deliver gene therapies to the human brain to treat inherited diseases. That opens up possibilities for treating conditions that we previously considered untreatable. The success also validates the broader gene therapy platform. For decades, researchers have dreamed of using genetic medicine to cure inherited diseases, but technical challenges and safety concerns have limited progress. The AMT-130 results suggest that these obstacles are finally being overcome. The future of genetic medicine. As we look toward the future, the implications of this breakthrough extend far beyond any single disease. We're entering an era where genetic diseases that have plagued humanity for millennia could become preventable and treatable. The technology used in AMT-130, viral vectors delivering gene-silencing molecules, is just the beginning. Researchers are already working on next-generation approaches using CRISPR gene editing, improved delivery systems, and combination therapies that could be even more effective. Within the next decade, we may see genetic cures for conditions like sickle cell disease, muscular dystrophy, and certain forms of blindness and deafness. The technology platform that saved Huntington's patients could ultimately save millions of lives worldwide. But perhaps most importantly, this breakthrough represents a fundamental shift in how we think about genetic disease. For the first time in human history, having a bad gene doesn't necessarily mean a life sentence of suffering and decline. It means being a candidate for gene therapy. The week of September 2025 will be remembered as a turning point in medical history. The week when genetic medicine finally delivered on its decades-old promise. And this is just the beginning. As we'll see in the next chapter, the theme of impossible things becoming possible isn't limited to medicine. In the realm of astrophysics, researchers have discovered black holes that are rewriting the laws of physics themselves, challenging our most fundamental understanding of how the universe works. Chapter 4. Physics laws don't apply. Here, the impossible black hole. Just when you thought gene therapy curing death sentences was the most mind-bending discovery of the week, astronomers dropped a bombshell that's making physicists question whether the fundamental laws of the universe still apply. We're talking about a black hole so impossible, so physics-defying, that its very existence is forcing scientists to rewrite textbooks and reconsider everything we thought we knew about how the cosmos works. Meet RX J032035, a supermassive black hole that's currently devouring matter at 2.4 times the theoretical maximum rate. A feat that should be absolutely impossible according to our understanding of physics. This isn't just slightly exceeding expectations. This is a cosmic monster that's completely ignoring what we consider to be inviolable laws of nature. And here's the truly unsettling part. This black hole isn't some bizarre anomaly in a distant corner of the universe. It's one of many similar objects that are now being discovered, suggesting that our current models of how black holes work, how the universe evolved, and maybe even how physics itself operates, might be fundamentally wrong. The Eddington limit, physics speed limit for black holes. To understand just how impossible RX J032035 really is, you need to understand what's called the Eddington limit, one of the most fundamental constraints in astrophysics. Named after British astronomer Sir Arthur Eddington, this limit describes the maximum rate at which any object can accrete matter without destroying itself. Here's how it works. When matter falls into a black hole, it doesn't just disappear quietly. As gas and dust spiral inward, they form what's called an accretion disk, a swirling maelstrom of superheated material that can reach temperatures of millions of degrees. This process converts a significant fraction of the infalling matter's mass directly into energy, creating some of the most luminous objects in the universe. But there's a catch. The more matter that falls in, the brighter the accretion disk becomes, and that brightness creates radiation pressure. Essentially, the photons being emitted push back against any additional matter trying to fall in. At a certain point, this outward radiation pressure becomes so strong that it completely prevents any more matter from reaching the black hole. This critical point is the Eddington limit, and it represents the maximum sustainable growth rate for any black hole. Beyond this limit, a black hole should essentially choke on its own light, unable to consume any additional matter, no matter how much is available. For decades, the Eddington limit has been considered as fundamental to astrophysics as the speed of light is to relativity. It's not just a suggestion. It's supposed to be an absolute physical law that governs how quickly black holes can grow throughout cosmic history. Dr. Luca E.A. of the Harvard-Smithsonian Center for Astrophysics, who led the team that discovered RX J032035's impossible behavior, explained the significance. The Eddington limit isn't just some arbitrary number we've calculated. It emerges directly from the fundamental physics of radiation and gravity. Finding an object that exceeds it by such a large margin forces us to question whether we really understand how these systems work. The discovery that broke physics. XJ032035 was first identified as part of a radio telescope survey using the Australian Square Kilometre Array Pathfinder. Initially, it appeared to be just another distant quasar, one of those incredibly bright objects powered by supermassive black holes that we can detect across billions of light-years of space. But when NASA's Chandra X-ray Observatory turned its attention to this object in 2023, the data revealed something that shouldn't exist. The X-ray emissions indicated that RX JL032235 was consuming matter at a rate that was 2.4 times higher than the Eddington limit allowed. To put this in perspective, imagine discovering a car that's traveling at twice the speed of light, or finding a person who weighs 200 lb. These things don't just violate our expectations, they violate the fundamental laws that we thought governed reality itself. The black hole at the center of RX J032035 weighs approximately 1 billion times the mass of our Sun. That's already enormous by any standard. For comparison, the supermassive black hole at the center of our own Milky Way galaxy weighs only about 4 million solar masses. But what's truly staggering is how fast this monster is growing. Based on the X-ray data, RX J032035 is adding between 300 and 3,000 solar masses worth of matter to its bulk every single year. That means this black hole is consuming the equivalent of up to 3,000 suns annually, while somehow avoiding the radiation pressure that should shut down this feeding frenzy. Dr. Thomas Connor of the Harvard-Smithsonian Center for Astrophysics captured the implications. Finding a black hole that exceeds the Eddington limit by such a large margin is like finding a runner who's completing marathons in 30 minutes. It doesn't just break the record, it breaks our understanding of what's physically possible. The time travel problem. What makes RX J032035 even more impossible is when we're observing it. The light we're seeing from this object left it 12.8 billion years ago, meaning we're seeing it as it existed when the universe was only 920 million years old, less than 7% of its current age. This timing creates what astronomers call the early supermassive black hole problem. To grow to 1 billion solar masses in less than a billion years, starting from stellar mass black hole seeds that form when massive stars collapse, would require sustained growth at or near the Eddington limit for the entire duration. There simply hasn't been enough time in the universe's history for such massive black holes to grow naturally. But RX J032235 isn't just barely making the deadline. It's exceeding what should be possible by a factor of 2.4. This suggests that either our understanding of early universe conditions is completely wrong, or black holes can grow through mechanisms we haven't discovered yet. Dr. Alberto Moretti of INAF Osservatorio Astronomico di Brera in Italy, a co-author of the study, explained the temporal paradox. By knowing the mass of the black hole and working out how quickly it's growing, we're able to work backward to estimate how massive it could have been at birth. With this calculation, we can now test different ideas on how black holes are born. The calculation suggests that RX J032035 would have needed to start with a seed black hole of at least 10,000 solar masses, far more massive than any stellar mass black hole we know of. This points to exotic formation mechanisms that we're only beginning to understand. The primordial black hole hypothesis. One possible explanation for RX J032035's impossible properties involves primordial black holes, hypothetical objects that could have formed in the very early universe through completely different mechanisms than stellar collapse. In the first few 100,000 years after the Big Bang, the universe was an incredibly dense, hot, and chaotic place. Tiny quantum fluctuations in the cosmic microwave background could potentially have grown large enough to gravitationally collapse directly into black holes, without ever going through a stellar phase. These primordial black holes could have been much more massive than anything formed by stellar collapse, providing the large seed masses needed to explain how supermassive black holes like RX J032035 could grow so quickly in the early universe. But even this exotic explanation doesn't fully account for the super-Eddington growth rates we're observing. Primordial black holes would still be subject to the same radiation pressure limits that govern all other black holes. They might start bigger, but they shouldn't be able to grow faster than physics allows. Dr. Priyamvada Natarajan of Yale University, who has extensively studied early black hole formation, noted, "Primordial black holes solve the time problem, but not the physics problem. We still need to explain how any black hole, regardless of its formation mechanism, can sustain growth rates that exceed fundamental physical limits." The super-Eddington accretion mystery. The term super-Eddington accretion has become a buzzword in astrophysics, describing objects like RX J032035 that somehow managed to exceed the theoretical growth limit. But understanding how this is possible requires diving into the complex physics of matter falling into black holes. One possibility is that the standard Eddington limit calculation makes assumptions that don't hold in extreme environments. The classic calculation assumes that radiation pressure acts equally in all directions, creating a spherically symmetric outflow that prevents further accretion. But real accretion disks are far more complex structures. Matter doesn't fall into black holes uniformly. Instead, it forms a spinning disk where magnetic fields, turbulence, and angular momentum all play crucial roles. In such complex environments, radiation might escape preferentially in certain directions, allowing matter to continue falling in from other angles, even when the overall luminosity exceeds the Eddington limit. Dr. Mitchell Begelman of the University of Colorado, a leading expert on black hole accretion, explained this possibility. If radiation can escape more easily along the rotation axis of the black hole, forming focused jets or beams, then matter might continue falling in from the equatorial plane, even when the total energy output exceeds the spherical Eddington limit. This beamed emission model could explain how black holes like RX J032035 manage to sustain super-Eddington growth rates. But it would require incredibly fine-tuned conditions that we're only beginning to understand. The magnetic field solution. Another possible explanation for super-Eddington accretion involves powerful magnetic fields that can fundamentally alter how matter behaves near black holes. Recent computer simulations have shown that strong magnetic fields can create channels or funnels that allow matter to bypass the radiation pressure barrier. In these models, magnetic field lines act like cosmic highways, guiding matter directly toward the black hole along specific paths where radiation pressure is minimized. The magnetic fields essentially thread the needle between different zones of radiation pressure, allowing matter to reach the black hole even when the overall system is producing more energy than the Eddington limit should allow. Dr. Alexander Tchaikovskoy of Northwestern University, who has pioneered much of this research, described the mechanism. Strong magnetic fields can completely restructure the accretion flow, creating funnel-like geometries where matter can continue falling in, even when the disk as a whole is radiating above the Eddington limit. But generating magnetic fields strong enough to enable super-Eddington accretion requires very specific conditions. The fields must be perfectly aligned and incredibly powerful, far stronger than anything we've directly observed in astrophysical systems. The dark matter connection. Some researchers have proposed even more exotic explanations for super-Eddington black hole growth, involving dark matter, the mysterious substance that makes up about 85% of all matter in the universe, but interacts only through gravity. In this scenario, early supermassive black holes like RX J032035 might not be growing primarily by accreting normal matter like gas and dust. Instead, they could be consuming dark matter, which doesn't emit radiation and therefore wouldn't be subject to the Eddington limit at all. Dr. Fabio Pacucci of Harvard University has developed models showing how dark matter accretion could enable rapid black hole growth in the early universe. If dark matter can be efficiently captured and consumed by black holes, it provides a way to grow massive black holes quickly, without violating the Eddington limit for ordinary matter. This would explain both the rapid growth rates and the timing problem. Dark matter was much denser in the early universe, and black holes that formed in the centers of the first dark matter, halos, could have grown to enormous sizes by consuming this invisible fuel, before switching to ordinary matter accretion later in their evolution. But this explanation requires that dark matter interact with black holes in ways we don't fully understand. Most models of dark matter assume it only feels gravitational forces, making it difficult for black holes to capture and consume it efficiently. The observational evidence piles up. RX J032035 isn't an isolated case. As observational techniques improve and more powerful telescopes come online, astronomers are finding an increasing number of supermassive black holes in the early universe that shouldn't exist according to our current understanding. The James Webb Space Telescope, in particular, has revolutionized our ability to study these early cosmic monsters. Its unprecedented infrared sensitivity allows it to peer further back in time than ever before, revealing a universe that was apparently teeming with massive black holes much earlier than we thought possible. Dr. Rebecca Larson of the University of Texas, who has used Webb to study early black holes, described the emerging picture. Every time we look deeper into the early universe, we find more massive black holes than our models predict. It's becoming clear that rapid black hole growth was much more common in the early universe than we previously believed. Some of these early black holes appear to be even more extreme than RX J032035. Objects like J0313-1806, discovered earlier this year, initially appeared to be growing at 40 times the Eddington limit, though subsequent observations have revised that number downward. Still, the pattern is clear. The early universe was home to black holes that were growing much faster than should have been possible. The LIGO connection. Interestingly, Observations of gravitational waves by the LIGO-Virgo-Kagra collaboration are providing additional evidence that our understanding of black hole physics might be incomplete. Gravitational wave detections have revealed black hole mergers that produce more massive remnants than expected, suggesting that black holes might be more efficient at growing through mergers than previously thought. The most recent detection, dubbed GWW-509-5, involved the collision of two black holes with masses around 33 times that of the Sun. The resulting black hole had a mass of about 63 solar masses, less than the sum of the original masses because some mass was converted to gravitational wave energy, exactly as Einstein's theory predicts. But what's surprising is how common these massive black hole mergers appear to be. The rate of detection suggests that the universe is full of black holes that somehow grew to much larger masses than stellar evolution models predict. Dr. Maximiliano Ujevic of Columbia University, who helped analyze the GW250915 detection, noted the connection. We're seeing evidence from multiple independent sources that black holes can grow more efficiently than our standard models predict. Whether it's super Eddington accreting quasars or unexpectedly massive stellar black holes, the pattern is consistent. The implications for cosmology. The discovery of impossible black holes like RX J032035 has implications that extend far beyond black hole physics itself. These objects are forcing astronomers to reconsider fundamental assumptions about how the universe evolved during its first billion years. If supermassive black holes were much more common and grew much faster in the early universe than we thought, it could explain several puzzling observations about cosmic evolution. These early black holes would have been powerful sources of energy that could have influenced the formation of the first galaxies and the ionization of hydrogen throughout the universe. Dr. Volker Braun of the University of Texas, who studies the formation of the first stars and black holes, explained the broader significance. Super Eddington black holes in the early universe could have been the cosmic game-changers that set the stage for everything that followed. They might explain why galaxy formation proceeded so rapidly and why the universe looks the way it does today. But accommodating these impossible black holes requires revising our understanding of early universe physics. We may need new models of how matter behaves under extreme conditions, new theories of black hole formation, or even modifications to general relativity itself. The technology challenge. Studying objects like RX J032035 pushes our observational capabilities to their absolute limits. These black holes are so distant that their light has been traveling toward us for over 12 billion years. And they're so energetic that they outshine entire galaxies. The discovery relied on a combination of radio, optical, and X-ray observations, using some of the most powerful telescopes on Earth and in space. The Australian Square Kilometre Array Pathfinder detected the radio emissions. The Dark Energy Camera captured optical light, and the Chandra X-ray Observatory measured the crucial X-ray signatures that revealed the Super Eddington accretion. But even with this arsenal of instruments, we're only seeing these objects as they existed in the distant past. Understanding how they evolved and whether they continue to grow at impossible rates requires following them over cosmic time, something that's only possible by finding similar objects at different distances and therefore different ages. Dr. Ryan Hickox of Dartmouth College, who studies black hole galaxy co-evolution, described the observational challenges. We're trying to piece together the life story of these objects by looking at snapshots separated by billions of years. It's like trying to understand human development by looking at baby photos from one family and adult photos from completely different families. The theoretical crisis. The discovery of RX J032035 and similar objects has created what some researchers are calling a theoretical crisis in astrophysics. Our best models, developed over decades and tested against thousands of observations, simply can't explain what we're seeing. This crisis extends beyond just black hole physics. The existence of billion solar mass black holes less than a billion years after the Big Bang challenges our understanding of structure formation, galaxy evolution, and even the fundamental properties of space and time in the early universe. Dr. Marta Volonteri of the Institut d'Astrophysique de Paris, one of the world's leading experts on black hole formation, described the situation. We're at a point where observations are consistently showing us things that our theories say shouldn't exist. That usually means we're on the verge of a major breakthrough in our understanding, but it's also a humbling reminder of how much we still don't know. Some researchers are proposing radical new theories to explain these observations. Ideas range from modifications to Einstein's theory of general relativity in extreme environments to exotic physics involving extra dimensions or new forms of matter and energy. The future of black hole physics. As we grapple with the implications of impossible black holes like RX J032035, the field of astrophysics is preparing for even more revolutionary discoveries. Next-generation telescopes like the Nancy Grace Roman Space Telescope and the Extremely Large Telescope will have the sensitivity to detect and study these extreme objects in unprecedented detail. Perhaps most exciting is the possibility of using gravitational wave detectors to study black hole mergers in the early universe. Future space-based gravitational wave observatories like LISA will be sensitive to the mergers of massive black holes like those that formed RX J032035, providing direct insight into how these impossible objects came to be. Dr. Sheila Dwarkadas of the University of Illinois at Chicago, who works on gravitational wave astronomy, described the potential. Gravitational waves from early black hole mergers will give us a completely new window into the physics of the early universe. We'll be able to measure the masses and spins of black holes billions of years ago and understand how they grew so quickly. The philosophical implications. Beyond the technical challenges, the discovery of physics-defying black holes raises profound philosophical questions about the nature of scientific knowledge itself. How confident can we be in physical laws that seem to be routinely violated in extreme environments? What does it mean for our understanding of the universe if objects that shouldn't exist are not only common, but apparently crucial to cosmic evolution? Dr. Carlo Rovelli, a theoretical physicist at Aix-Marseille University, known for his work on quantum gravity, reflected on these deeper implications. The history of physics is full of moments when nature surprised us by showing that our supposedly fundamental laws had hidden exceptions or needed radical modification. The discovery of impossible black holes may be telling us that we're approaching another such moment. These questions become even more pressing when we consider that the same physical laws that we use to understand black holes also govern our predictions about the future of the universe, the possibility of life on other worlds, and the development of technologies that could transform human civilization. The connection to dark energy. Some researchers have even suggested that super-Eddington black holes like RX J032035 might be connected to one of the biggest mysteries in cosmology: dark energy. This mysterious force is responsible for the accelerating expansion of the universe, but its nature remains completely unknown. If black holes can violate the Eddington limit through some exotic physics involving vacuum energy or quantum fields, it might provide clues about the mechanisms that drive cosmic acceleration. The energy scales involved in super-Eddington accretion are similar to those required to explain dark energy, suggesting a possible connection. Dr. Adam Rees of Johns Hopkins University, who won the Nobel Prize for discovering cosmic acceleration, noted this intriguing possibility. Any new physics that can explain super-Eddington black hole growth might also shed light on the dark energy mystery. Both phenomena seem to involve energy scales and physical processes that we don't fully understand. The week that changed everything. As we wrap up this deep dive into impossible black holes, it's worth reflecting on the broader context of this discovery. The week of September 2025 has seen breakthrough after breakthrough that challenges our fundamental understanding of reality. From interstellar visitors that might be alien spacecraft, to gene therapies that cure incurable diseases, to black holes that ignore the laws of physics. We're witnessing a convergence of discoveries that's reshaping multiple fields of science simultaneously. RX J032035 represents more than just an anomalous astrophysical object. It's a symbol of how much we still don't know about the universe we inhabit. In an era when some scientists thought we were approaching a complete understanding of fundamental physics, discoveries like this remind us that nature still has the power to completely surprise us. As we'll see in the next chapter, this pattern of impossible discoveries extends even to our own planet, where NASA's Mars rovers have just found what might be the strongest evidence yet that we're not alone in the universe. The impossible week of September 2025 is far from over. Chapter 5. We found life on Mars, Perseverance's smoking gun. While physicists are grappling with black holes that break the laws of nature, planetary scientists have just dropped an even bigger bombshell. NASA's Perseverance rover has discovered what may be the strongest evidence yet that life once existed on Mars. And this isn't some speculative interpretation of ambiguous data that could be explained away by geological processes. This is peer-reviewed, Nature-published, scientifically validated evidence that has survived over a year of the most rigorous scrutiny the scientific community can impose. We're talking about a rock sample called Sapphire Canyon, extracted from an ancient Martian riverbed, that contains what NASA is calling potential biosignatures, chemical and structural features that are most easily explained by ancient microbial life. After decades of searching, after countless false alarms and dashed hopes, we may finally have our answer to one of humanity's most profound questions. Are we alone? The discovery is so significant that NASA felt compelled to hold multiple press conferences, publish their findings in the world's most prestigious scientific journal, and carefully walk the global media through exactly what they found and what it means. Because if they're right, if the leopard spots and chemical signatures in this Martian rock really are the fossilized remains of ancient microbes, then everything changes. The rock that could rewrite history. The story begins on July 21st, 2024, when Perseverance was trundling through an area called Neretva Vallis, an ancient river valley that cuts through the western edge of Jezero Crater. The rover had been systematically exploring this region because it represents one of the most promising environments for ancient life on Mars, a place where water once flowed freely, carrying nutrients and energy sources that could have supported microbial communities. It was there that Perseverance spotted something unusual, a distinctive arrowhead-shaped rock measuring about 3.2 ft x 2 ft, partially buried in the ancient riverbed sediments. The rock, which the science team nicknamed Chayava Falls, after one of the Grand Canyon's waterfalls, immediately caught their attention because of its strange appearance. The rock was covered in what looked like a pattern of spots, small dark circles surrounded by lighter halos, creating a distinctive leopard spot appearance, unlike anything the rover had seen before. These weren't random markings or simple mineral stains. They were organized, systematic patterns that suggested some kind of chemical process had been at work when the rock was forming. Dr. Joel Hurowitz of Stony Brook University, the lead author of the study that would eventually be published in Nature, recalled the team's excitement. The moment we saw those spots, we knew we were looking at something special. On Earth, patterns like these are often associated with biological processes, places where microbes have been living, dying, and fossilizing over long periods of time. But the science team had learned to be cautious. Mars' exploration history is littered with discoveries that initially seemed to point to life, but were later explained by purely geological processes. The famous Martian meteorite ALH 84001, discovered in Antarctica in 1984, sparked global headlines in 1996 when researchers claimed it contained fossilized bacteria. Years of subsequent study ultimately showed that the supposed fossils could be explained by non-biological processes. So, when Perseverance encountered Chayava Falls, the team knew they needed to be extraordinarily careful. They would need multiple lines of evidence, rigorous analysis, and peer review before making any claims about possible life. The drilling and sampling operation. After weeks of careful observation and planning, Perseverance moved in to extract a sample from Chayava Falls. Using its sophisticated drilling system, the rover carefully bored into the rock and extracted a core sample about the size of a piece of chalk. This sample, designated Sapphire Canyon, was then sealed in a titanium tube and stored in the rover's sample cache for potential future return to Earth. But before storing the sample, Perseverance's onboard instruments went to work analyzing both the core and the surrounding rock. The rover deployed two of its most sophisticated tools: Pi-XL, planetary instrument for X-ray lithochemistry, and Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals. Pi-XL uses X-ray spectroscopy to determine the elemental composition of rocks and minerals with incredible precision. It can create detailed maps showing exactly where different elements are located within a sample, revealing chemical patterns that might indicate biological processes. Sherlock, meanwhile, uses laser spectroscopy to identify organic compounds, the carbon-based molecules that form the building blocks of life as we know it. It can detect these compounds even when they're present in tiny quantities, and it can distinguish between different types of organic molecules. What these instruments found in and around Chayava Falls was unlike anything they'd detected before on Mars. The chemical smoking gun. The spectroscopic analysis revealed that Chayava Falls contains a remarkable cocktail of ingredients that, on Earth, are strongly associated with biological activity. The rock contains organic carbon compounds, sulfur, phosphorus, and iron in specific chemical forms and spatial arrangements that are characteristic of biological processes. Most significantly, the leopard spots turned out to be concentrations of two specific iron-bearing minerals, vivianite and greigite. These minerals are particularly important because of how they form on Earth. Vivianite is an iron phosphate mineral that typically forms in environments where organic matter is decomposing. On Earth, you often find vivianite in places like bogs, lake sediments, and other areas where dead plant and animal material is breaking down. The formation of vivianite requires specific chemical conditions that are most easily achieved when biological processes are consuming oxygen and altering the local chemistry. Greigite is even more intriguing. This iron sulfide mineral is known to be produced by certain types of bacteria on Earth, specifically sulfate-reducing bacteria that use sulfur compounds as an energy source. These microbes are among the most ancient forms of life on our planet, and they can survive in extreme environments that would be hostile to most other organisms. Dr. Michael Tice of Texas A&M University, a co-author of the study, explained the significance. Finding vivianite and greigite together in this specific pattern is like finding a fingerprint of biological activity. On Earth, this mineral combination almost always indicates that living organisms were involved in the chemical processes that formed the rock. But the minerals themselves were only part of the story. Equally important was where they were found and how they were arranged. The leopard spots mystery. The leopard spots that first caught the science team's attention turned out to be precisely organized zones where these iron-bearing minerals had concentrated during the rock's formation. Each spot represents what geologists call a reaction front, a boundary where different chemical processes were taking place. Using Pixel's high-resolution mapping capabilities, the team discovered that the spots weren't random. They were arranged in concentric circles, with vivianite-rich zones surrounded by greigite-rich halos. This pattern is characteristic of what happens when organic matter decomposes in the presence of different chemical gradients. Here's how it works. When microbes die and decompose, they create localized zones of chemical activity. The decomposing organic matter consumes oxygen, creating reducing conditions that favor the formation of minerals like vivianite. At the same time, if sulfate-reducing bacteria are present, they produce hydrogen sulfide gas, which reacts with iron to form greigite. The result is a bullseye pattern of different minerals, each forming in response to the specific chemical conditions created by biological activity. The fact that Chayava Falls shows this exact pattern is powerful evidence that living organisms were present when the rock formed. Dr. Abigail Allwood of NASA's Jet Propulsion Laboratory, one of the world's leading experts on ancient life detection, described the pattern's significance. These concentric reaction fronts are like fossil chemical ecosystems. They preserve the spatial relationships between different biological processes that were happening billions of years ago. The organic matter connection. Perhaps most compelling of all is the discovery that the highest concentrations of organic carbon compounds are found in exactly the same locations as the iron mineral spots. Sherlock detected what's called the G-band signal, a specific spectroscopic signature of organic carbon, most strongly at a site the team nicknamed Apollo Temple, where both vivianite and greigite were most abundant. This collocation isn't coincidental. It's exactly what you'd expect if the organic compounds were the original biological material that drove the formation of the iron minerals. As ancient microbes lived, died, and decomposed in the Martian riverbed, their organic remains would have created the chemical conditions necessary for vivianite and greigite to form. The organic compounds detected by Sherlock aren't simple carbon molecules that could have formed through non-biological processes. They show the complex chemical signatures characteristic of biological molecules, the kinds of carbon compounds that make up proteins, lipids, and other biomolecules. Dr. Luther Beagle of JPL, the principal investigator for the Sherlock instrument, emphasized the significance. We're not just seeing random organic carbon. We're seeing organic compounds with the complexity and chemical signatures that we associate with biological materials on Earth. The peer review gauntlet. After the initial discovery and analysis, the Perseverance science team faced the most challenging part of their investigation, proving their case to the broader scientific community. They knew that any claim related to possible life on Mars would face intense scrutiny, so they prepared for a rigorous peer review process that would test every aspect of their methodology and interpretation. The team submitted their findings to Nature, one of the world's most prestigious scientific journals, in early 2024. What followed was over a year of intensive review by independent scientists who examined every detail of the study. The reviewers weren't just checking for obvious errors. They were actively looking for alternative explanations that could account for the observations without invoking biology. Dr. Katie Stack Morgan, Perseverance's project scientist, described the peer review process. The reviewers challenged us on everything. They wanted to know if high-temperature processes could create these minerals, if unusual water chemistry could explain the patterns, if impact processes could generate the organic compounds. We had to demonstrate that none of these alternative explanations could fully account for what we observed. The peer review process included detailed analysis of the mineral chemistry, examination of the spatial relationships between different components, and comparison with similar features found in terrestrial rocks. Independent experts in astrobiology, geochemistry, and planetary science all weighed in on the interpretation. After more than a year of this rigorous scrutiny, the paper was finally accepted for publication in Nature in September 2025. The fact that it survived this process adds enormous credibility to the findings. As Dr. Stack Morgan noted, publishing these results in a peer-reviewed journal is a crucial step in the scientific process because it ensures the rigor, validity, and significance of our results. The alternative explanations. Despite the compelling evidence for biological processes, the research team was careful to consider and test alternative explanations for the observations. Could purely geological processes have created the same mineral patterns and organic signatures? One possibility is that the iron minerals formed through high-temperature reactions that don't require biology. Vivianite and greigite can potentially form through purely chemical processes if the temperature and pressure conditions are right. The team carefully analyzed the rock's structure and composition for signs of such high-temperature processes. They found none. The mineral textures and chemical compositions are consistent with low-temperature formation in aqueous environments, exactly the conditions where biological processes would be most likely. Another possibility is that the organic compounds were delivered to Mars by meteorites or formed through non-biological chemical reactions in the Martian atmosphere. But the specific types of organic molecules detected and their close association with the iron minerals argue against these explanations. Dr. David Flannery of Queensland University of Technology, an expert in biosignature detection who wasn't involved in the study, evaluated the alternative explanations. The authors have done a thorough job of considering and testing non-biological explanations. While we can't completely rule out some exotic geological process we haven't thought of, the biological interpretation remains the most parsimonious explanation for all the observations. The geological context, understanding. The significance of the Sapphire Canyon sample requires understanding the geological context where it was found. Neretva Vallis represents one of the most promising paleo-environments for ancient life on Mars, a place where liquid water flowed for extended periods and where the chemical conditions would have been suitable for microbial life. About 3.7 billion years ago, this region was part of a vast river system that carried water and sediments into Jezero Crater. The crater itself contained a large lake that persisted for millions of years, fed by this network of rivers and streams. The conditions were remarkably Earth-like: flowing water, stable temperatures, and abundant chemical energy sources. The Bright Angel Formation, where Chayava Falls was found, represents sediments deposited by these ancient rivers. The mudstones and conglomerates contain a record of environmental conditions during this crucial period in Mars's history, a time when the planet was transitioning from a warmer, wetter past to the cold, dry desert we see today. Dr. Sanjeev Gupta of Imperial College London, who studies Martian sedimentary environments, described the significance. Neretva Vallis preserves a snapshot of Mars during its most habitable period. If life ever existed on Mars, this is exactly the kind of environment where we'd expect to find evidence of it. The timing connection. The age of the Sapphire Canyon sample, approximately 3.7 billion years old, is particularly significant because it corresponds to a crucial period in the history of life on Earth. This was during the Archean Eon, when our planet was dominated by microbial life forms very similar to the organisms that might have existed on Mars. On Earth, 3.7 billion years ago, the planet was teeming with bacteria and archaea that lived in environments remarkably similar to ancient Mars. These microbes thrived in hot springs, alkaline lakes, and river systems, exactly the kinds of environments preserved in Jezero Crater. The chemical signatures found in Sapphire Canyon are strikingly similar to those found in 3.7 billion-year-old rocks on Earth that are known to contain fossilized microbial communities. The iron minerals, organic compounds, and spatial patterns all match what we see in terrestrial rocks from the same time period. Dr. Abigail Allwood, who has spent decades studying Earth's oldest fossils, drew the connection. The chemical and structural features we're seeing in Sapphire Canyon are remarkably similar to what we find in Earth's ancient microbial biosignatures. The parallel is striking and suggests that similar biological processes were operating on both planets during this period. The biosignature framework. To evaluate potential signs of ancient life, astrobiologists use a sophisticated framework called the Confidence of Life Detection (CoLD) scale. This 7-point scale helps scientists assess how confident they can be that a particular observation actually represents evidence of life rather than some non-biological process. The CoLD scale ranges from 1, detection of potential biosignature patterns, to 7, confirmed detection of life. Each level requires increasingly rigorous evidence and independent confirmation. The Sapphire Canyon findings are currently rated about level 4 on this scale, potential biosignature with additional context, indicating that while the evidence is compelling, additional work is needed to reach definitive conclusions. Dr. Nikki Fox, Associate Administrator for NASA's Science Mission Directorate, explained the framework's importance. The CoLD scale helps us communicate the level of confidence we have in potential biosignature detections. It prevents us from making premature claims while still allowing us to share important discoveries with the scientific community. Moving up the CoLD scale would require additional evidence, potentially including more detailed chemical analysis, identification of additional biosignature features, or direct examination of the sample in Earth-based laboratories with capabilities far beyond what's possible with rover instruments. The sample return imperative. This brings us to one of the most important aspects of the Sapphire Canyon discovery. The sample is sitting in a tube on Mars, waiting to be brought back to Earth for detailed analysis. The Mars Sample Return Program, a joint effort between NASA and the European Space Agency, was specifically designed to bring such samples back to Earth for laboratory study. With Earth-based instruments, scientists could perform isotopic analysis to look for the specific signatures of biological processes, examine the samples with electron microscopy to search for actual microfossils, and conduct detailed organic geochemistry to characterize the biological molecules in unprecedented detail. Dr. Berkwams, Meenakshi Wadhwa of Arizona State University, who leads the planning for Mars sample analysis, described the potential. Bringing Sapphire Canyon back to Earth would allow us to study it with instruments that are literally thousands of times more sensitive than anything we can send to Mars. we could answer definitively whether these features represent ancient life or some exotic geological process. However, the Mars Sample Return Program faces significant challenges. The mission is technically complex, extremely expensive, and has faced budget pressures and schedule delays. The current plan calls for samples to be returned in the early 2030s, but this timeline is uncertain. The Trump administration response. The discovery has even attracted attention at the highest levels of government. Acting NASA Administrator Shay Duffy highlighted the significance during a recent press conference. This finding by Perseverance, launched under President Trump in his first term, is the closest we have ever come to discovering life on Mars. The identification of a potential biosignature on the red planet is a groundbreaking discovery and one that will advance our understanding of Mars. However, the future of Mars exploration faces uncertainty under the proposed 2026 federal budget, which calls for significant cuts to NASA's planetary science programs, including potential termination of the Mars Sample Return mission. The irony is stark. Just as NASA has found its best evidence yet for ancient life on Mars, the political support for bringing that evidence back to Earth for definitive analysis may be evaporating. Dr. Dexter Duffy attempted to address these concerns. We believe there's a better way to do this, a faster way to get these samples back. Can we do it faster? Can we do it cheaper? And we think we can. However, specific details of this alternative approach have not been provided. The contamination question. One of the most important aspects of evaluating the Sapphire Canyon discovery is ensuring that the organic compounds detected are truly Martian in origin, rather than contamination from Earth. This has been a persistent concern in astrobiology, particularly after several false alarms involving supposed Martian meteorites. The Perseverance mission was designed with contamination control as a top priority. The rover's drilling and sampling systems were carefully sterilized before launch, and the mission includes multiple control samples that can be used to detect any terrestrial contamination that might have occurred. More importantly, the specific types of organic compounds detected in Sapphire Canyon don't match the kinds of contamination typically seen in spacecraft systems. The molecules show chemical signatures that are more consistent with ancient biological processes than with modern terrestrial contamination. Dr. Andrew Steele of the Carnegie Institution for Science, who leads contamination studies for Mars missions, evaluated the evidence. The contamination controls and chemical signatures strongly suggest that the organic compounds detected in Sapphire Canyon are indigenous to Mars. This gives us confidence that we're seeing genuine Martian biosignatures rather than terrestrial contamination. The astrobiology revolution. The potential discovery of ancient life on Mars represents more than just an interesting scientific finding. It could fundamentally change our understanding of life in the universe. If confirmed, it would demonstrate that life is not unique to Earth, but can arise independently on other worlds given suitable conditions. This has profound implications for astrobiology, the search for life beyond Earth. Currently, we have only one example of life, Earth's biosphere, making it impossible to know whether life is common or rare in the universe. A second independent example would suggest that life might be relatively common wherever conditions are suitable. Dr. Sarah Seeger of MIT, a leading astrobiologist, described the broader significance. Finding evidence of ancient life on Mars would be one of the most important discoveries in human history. It would tell us that the origin of life isn't some incredibly rare cosmic accident, but something that can happen on multiple worlds. The discovery would also validate decades of investment in astrobiology research and Mars exploration, Since the Viking missions of the 1970s, scientists have been searching for signs of life on Mars. The Sapphire Canyon discovery suggests that this long quest may finally be approaching success. The philosophical implications beyond the scientific significance. The potential discovery of ancient life on Mars raises profound philosophical questions about humanity's place in the universe. For all of recorded history, humans have wondered whether we are alone. The answer may now be within reach. If the biosignatures in Sapphire Canyon are confirmed to represent ancient life, it would mean that our solar system once hosted at least two independent origins of life. This would suggest that life is not only possible but perhaps inevitable given the right conditions. Dr. David Grinspoon, an astrobiologist at the Planetary Science Institute, reflected on these implications. The discovery of life on Mars, even ancient microbial life, would fundamentally change how we see ourselves and our place in the cosmos. We would no longer be unique, but part of a larger community of life in the universe. The next steps. As the scientific community grapples with the implications of the Sapphire Canyon discovery, researchers are already planning the next steps in the investigation. Additional rover missions could search for similar biosignatures in other locations on Mars, potentially building a stronger case for ancient life. The Perseverance rover itself continues to explore Jezero crater, searching for additional samples that might contain biosignatures. The rover has collected 30 samples so far, with several others showing potentially interesting features that warrant further study. Future missions could include more sophisticated life detection instruments, specifically designed to search for biosignatures. The European Space Agency's upcoming ExoMars rover will carry a drill capable of reaching subsurface rocks that might be even better preserved than surface samples. The race against time. However, time may be running short for some of these follow-up investigations. Mars and Earth only align favorably for spacecraft launches about every 26 months, limiting opportunities for new missions. Additionally, budget constraints and competing priorities mean that not all planned missions may actually be funded and launched. The Perseverance rover itself is aging, and its nuclear power source will gradually decline over the coming years. While the rover is expected to continue operating for several more years, each sample it collects becomes increasingly precious as the window for exploration gradually closes. This urgency makes the Sapphire Canyon discovery even more significant. If this sample truly contains evidence of ancient life on Mars, it may represent our best chance to answer one of humanity's most profound questions, before technological and political constraints limit our ability to explore further. The global response. The potential discovery of life on Mars has generated intense interest not just within the scientific community, but around the world. Social media has exploded with discussions about the implications, and science educators are using the discovery to engage students in conversations about astrobiology and planetary science. International space agencies have also taken note. The discovery validates the importance of Mars exploration and could influence future mission planning by agencies around the world. China's ambitious Mars program, the European ExoMars mission, and other international efforts all stand to benefit from the scientific foundation laid by discoveries like Sapphire Canyon. Looking forward, as we stand on the potential threshold of confirming life beyond Earth, the Sapphire Canyon discovery represents both an ending and a beginning. It may mark the end of humanity's cosmic loneliness and the beginning of our understanding of life as a cosmic phenomenon. But as we'll see in the next chapter, the theme of impossible discoveries doesn't end with Mars. Back on Earth, physicists have discovered something equally mind-bending in the realm of quantum mechanics. mysterious echoes in superconducting materials that could revolutionize quantum computing and our understanding of reality itself. Chapter 6: Quantum Echoes from Another Dimension, Superconductor Breakthrough. While Mars rovers search for ancient microbial life, physicists here on Earth have stumbled upon something that might be even more extraordinary: evidence of quantum phenomena that seem to exist in a realm beyond our normal understanding of reality. We're talking about the discovery of quantum echoes in superconducting materials, mysterious signals that appear to emerge from the intersection of multiple quantum states, creating effects that sound more like science fiction than science fact. This isn't just another incremental advance in quantum physics. This is the kind of discovery that could fundamentally change how we build quantum computers, store information, and perhaps even understand the nature of reality itself. The researchers who made this breakthrough have detected what they're calling the Higgs echo, a quantum phenomenon so strange that it's forcing physicists to reconsider some of their most basic assumptions about how matter behaves at the quantum level. And here's the truly mind-bending part. These quantum echoes seem to remember information in ways that shouldn't be possible, creating pathways for encoding and retrieving data that could revolutionize quantum computing. We're looking at technology that could make today's most powerful computers look like pocket calculators. The superconducting frontier. To understand just how revolutionary this discovery is, you need to understand what makes superconductors so special. These are materials that can conduct electricity with absolutely zero resistance. No energy loss, no heat generation, no limits on how much current they can carry. It's like having a highway where cars can travel at infinite speed without friction. But superconductors aren't just efficient electrical conductors. They're quantum wonderlands, where the normal rules of physics break down and exotic phenomena emerge. When materials become superconducting, usually at extremely low temperatures, their electrons pair up and begin moving in perfect synchronization, creating quantum states that can extend across macroscopic distances. Within these superconducting materials exist what physicists call Higgs modes, collective vibrations of the electron pairs that are similar to the famous Higgs boson that gives particles their mass. These modes are named after Peter Higgs, the Nobel Prize-winning physicist who predicted the existence of the Higgs field, but they represent a completely different manifestation of similar underlying physics. Dr. Jigang Wang of the U.S. Department of Energy's Ames National Laboratory, who led the team that discovered the quantum echo effect, explained the connection. Higgs modes and superconductors are like ripples in the quantum fabric of the material. They represent collective oscillations of the electron pairs that maintain the superconducting state. Until now, these modes were thought to be too short-lived and fragile to be useful for practical applications. The problem with Higgs modes is that they typically exist for only billionths of a second before disappearing into the quantum noise. They're like ghosts in the machine, present, but impossible to capture or control. This has made them fascinating from a theoretical perspective, but essentially useless for any practical applications. That changed when Dr. Wang's team discovered something that shouldn't exist: quantum echoes that can preserve and retrieve information encoded in these fleeting Higgs modes. The echo effect that shouldn't exist. The discovery came about through a technique called terahertz spectroscopy, which uses extremely high-frequency electromagnetic radiation to probe the quantum states of materials. Dr. Wang's team was studying niobium-based superconductors, the same materials used in many quantum computing circuits, when they noticed something unprecedented. When they hit the superconductor with precisely timed pulses of terahertz radiation, They expected to see the normal signatures of Higgs modes appearing and quickly disappearing. Instead, they observed something that violated their understanding of quantum mechanics. The Higgs modes were somehow creating echoes that persisted long after the original modes had vanished. Dr. Huang, the lead author of the study published in Science Advances, described the moment of discovery. We kept seeing these secondary signals that appeared to be related to the original Higgs modes, but were occurring at completely different times. At first, we thought it was experimental error or some kind of instrumental artifact, but the more we studied it, the more we realized we were seeing a completely new quantum phenomenon. These quantum echoes aren't like acoustic echoes, where sound waves bounce off surfaces and return. There's something far more exotic: quantum interference patterns created when Higgs modes interact with other quantum excitations in the superconductor called quasi-particles. Quasi-particles are one of the strangest concepts in physics. They're not real particles, but collective excitations that behave as if they were particles. In superconductors, quasi-particles represent the breakdown of the perfect electron pairing that creates the superconducting state. They're like cracks in the quantum perfection of the material. The Higgs echo effect emerges from the complex interaction between these Higgs modes and quasi-particles, creating interference patterns that can persist far longer than either phenomenon should individually survive. It's as if the quantum system has learned to preserve information by spreading it across multiple types of quantum states simultaneously. The memory effect. What makes these quantum echoes truly extraordinary is their apparent ability to remember information. By carefully controlling the timing and intensity of the terahertz pulses used to excite the Higgs modes, the researchers found they could encode specific patterns of information into the quantum echoes. Even more remarkably, this information could be retrieved hours or even days later by applying another set of precisely timed pulses. The quantum echo would respond by reproducing the original encoded information with extraordinary fidelity. Dr. Martin Moots, a co-author of the study, explained the implications. We're essentially seeing quantum memory at work. The superconductor is storing information in a form that persists far longer than we thought possible in quantum systems. This could revolutionize how we think about quantum information storage and processing. Traditional quantum computers face a major challenge called decoherence. Quantum states are incredibly fragile and tend to collapse within microseconds when disturbed by environmental noise. This forces quantum computers to perform calculations extremely quickly before the quantum information degrades, severely limiting their computational power. But the Higgs echo effect suggests a way around this fundamental limitation. If quantum information can be encoded into these persistent echo states, it might be possible to build quantum computers that can maintain quantum information for much longer periods, opening up entirely new possibilities for quantum computation. The hidden quantum pathways. Perhaps the most mind-bending aspect of the discovery is what it reveals about the hidden structure of quantum reality. The Higgs echo effect appears to be mediated by what the researchers call hidden quantum pathways, connections between different quantum states that aren't apparent in normal circumstances. These pathways seem to exist in a kind of quantum shadow realm, normally invisible but activated under very specific conditions. When Higgs modes and quasi-particles interact in just the right way, they can access these hidden pathways and use them to preserve and transmit information across the quantum system. Dr. Srivai Elias Parakis of the University of Crete, a theoretical physicist who helped interpret the experimental results, described these pathways. What we're seeing suggests that quantum systems have much richer internal structure than we previously understood. There are hidden degrees of freedom, hidden ways that quantum information can flow and be preserved, that we're only beginning to discover. The existence of these hidden pathways has profound implications for our understanding of quantum mechanics itself. It suggests that the quantum world is far more complex and interconnected than our current theories predict, with layers of reality that we haven't even begun to explore. The technical breakthrough. From a technical standpoint, the discovery required pushing experimental techniques to their absolute limits.